Hello viewers, welcome to video number 76 of the channel Chemphilic, and video number 76 is the 18th episode of Chemical Thermodynamics, and the topic of this 18th episode is concept of Wmax and work done in reversible process. In my last video, we have derived the expression of work done during the isothermal expansion of ideal gas, and we have seen that the expression of work done in isothermal reversible expansion of ideal gas is W is equal to nRT into 2.303 log of V2 by V1, or it is equal to nRT into 2.303 log of P1 by P2, where V2 is the final volume after expansion, V1 initial volume, and here P1 is the initial external pressure and P2 is the final external pressure, and this W sign will be negative because it is the work of expansion, that is work is done by the gas. Now first we are going to derive the expression of heat absorbed during isothermal reversible expansion of ideal gas. So what is the expression of heat absorbed? We know that from first law of thermodynamics, heat absorbed at constant pressure, that is equal to dE, change in internal energy, because absorbed heat, it increases the internal energy or thermal energy of the system, plus the system performs the pressure volume work, or overall we can write it as QP is equal to delta E plus P delta V. Okay, absorbed heat divided into two parts. One part increases internal energy, one part utilized for doing the pressure volume work by the gas. Now it is isothermal, that means temperature is constant. So at constant temperature means this change in the internal energy is zero. Earlier I explained, because internal energy is the function of temperature. If there is no change in temperature, there will be no change in internal energy. So heat absorbed will be completely utilized for doing the pressure volume work, that is P delta V. Therefore, expression of the work done during isothermal reversible expansion of ideal gas is exactly same as that of the expression of heat absorbed. So Q also I can write it as nRT into 2.303 log of V2 by V1, or nRT into 2.303 log of P1 by P2. So these two expressions are same, work done and heat absorbed during isothermal reversible expansion. Similarly, during compression also, heat release and this work done on the system, those two expression will be same. and here heat is absorbed, so sign will be positive. We are taking positive sign. Now, next topic is this work done on the system during isothermal reversible compression. Okay. Now once again let us consider this is the gaseous system, okay, enclosed in a cylinder which is attached with the weightless frictionless piston, okay, and initially this volume of the gas, that means this much is V2, and then external pressure which is acting downwards on the gas, that external pressure is decreased by a very infinitesimally small amount. When the external pressure is decreased by infinitesimally small amount, the gas pressure which is acting upwards, that will be little more than or infinitesimally more than that of the external, infinitesimally, once again I am telling you, when this external pressure is increased by infinitesimally small amount, then the gas pressure which is acting upwards, that will be infinitesimally less than that of the external pressure. So what happened? This piston will move downwards direction. That means the compression takes place by small volume. Say the piston is moved by the small distance, say this is dl. Again the external pressure is, if the external pressure is increased by infinitesimally small amount, say dp, again what will happen? The piston will move little distance in the downwards direction. And if this process is repeated for large number of time, then there will be a final contraction of this volume. Say, now initially volume was V2 this much, now volume is this one, that is V1. Okay. So, therefore, the gas is compressed from volume V2 to V1, okay, and this V2 is greater than your V1. If compression occurs, V2 is greater than this V1, okay. Now this is the compression. How the compression takes place? It takes place through a large number of steps. So this external pressure P external is increased by infinitesimally small amount dp. So the piston moves downwards, because then what will happen? As P external become greater than pressure of the gas. Okay. So therefore little volume is increased by, therefore volume is decreased by decreased by, how much volume is decreased? Say it is dV. Okay. So every time it is decreasing, it is coming downwards to a small distance dl. That means small volume is decreased by dV. So therefore, work done on the gas during contraction. Now here it is contraction. Work done on the gas during contraction, dash W will be is equal to P plus, say this is del W, P plus dP into dV. Okay. So del W is equal to P dV plus dP into dV. dP is very small, dV is very small, the product will be very small. So del W is equal to P dV. Okay. So W will be is equal to your volume. What is the initial volume? V2. Final volume V1. Then P dV. Okay. Now this P, external pressure, every step external pressure is increased by very small amount, infinitesimally small amount. So in each step it is constant external pressure, but it is different from one step to other. Here the external pressure is say P external. Here external pressure is P external plus dP. Here external pressure is P external plus dP plus dP. So each step it is constant, but in different step it will be different. So therefore P cannot be taken as constant. I cannot take it outside of the integration of sign. I have to convert it in terms of volume. So we know that PV is equal to nRT. So your P is equal to nRT by V. Okay. So therefore we can write it as this W is equal to here this integration V2 to V1 in place of P nRT dV by V. So if I take nRT, because n is constant, R is constant, temperature constant, isothermal process. So nRT, then integration V2 to V1, this is V1, then dV by V. So next line what will come? W will be is equal to, this W will be is equal to nRT into ln dV by V, final by initial. Final pressure is here, sorry, final volume is V1, initial is V2. So this we can write it as nRT into 2.303 log of V1 by V2, or we can write it as W is equal to nRT into 2.303 log of this, log of P2 by P1. Earlier I have shown you, because P1 V1 is equal to P2 V2. So V1 by V2 will be P2 by P1 at constant temperature. Okay. So this is the expression for work done on the gas during isothermal reversible compression. Now here one thing you observe. See, during compression, every step pressure is increased by very small amount dP. So pressure is increased. So pressure part will be positive, but volume is decreasing. Volume part will be negative. So positive, negative, negative. So here it is coming negative. But after coming to this expression V1 by V2, okay, V1 is less than V2, right? You're compressed from volume V2 to V1. Okay, initial volume V2, final volume is V1. So V1 is less than V2. So V1 is less than V2 means log V1 by V2 will be negative. And here because of the pressure volume, pressure positive, volume negative, this part will be negative. So negative negative become positive. Okay. So work done on the gas by the surrounding, that will be of positive side. Okay. Now next one is work done during isothermal irreversible expansion. In irreversible process, the pressure is decreased suddenly by large amount in one step. So here P external, it is expansion. So P external is decreased in one step by finite amount or large amount, by say finite amount. Okay, suddenly the P external is decreased. Okay, and say the volume increased from V1 to V2. Now P external is decreased suddenly in one step by finite amount. So that final P external, say let final P external, I am taking it as P2. So gas is working, or work of expansion done by the gas against this final external pressure P2. Okay. So the work done will be is equal to work done by the gas, that will be is equal to this final external pressure and the change in the volume, that is final volume minus initial volume. So this is the work done by the gas during isothermal reversible expansion. Pressure suddenly decreased by large amount, say that is P2, and gas is working against this final external pressure P2. So P2 into the change in the volume. Okay. Now coming to the next topic, that is the work done in reversible process is maximum. Now this work done in the reversible process, what we have observed, that say work of expansion, work done by the gas, then that del W, that will be is equal to, it is in the reversible process, that will be what we have written, P external, we are writing by P minus dP into dV. For each small step, reversible process means it is taking place to a large number of infinitesimally small steps. So every step where pressure is decreased by a very small amount, infinitesimally small amount. So this part, pressure, external pressure part is more, decrease is very small. So if the external pressure is more, then work done will be more for same change of this volume. So every step, external pressure is decreased by little amount dP. That means gas is working against more external pressure. So more external pressure means this overall value will be more. So work done will be more. So In reversible process, work done is maximum. In irreversible process, what happened? Suddenly the external pressure is decreased by large amount, so P will be less. If the pressure is less, then the gas is working against less external pressure. This part is less, so work done will be less. So work done in reversible process is maximum. Hope you have understood. Thank you.